Howdy y'all, I'm Joe Hughes, and I'm here for my session entitled Automating Template Creation with Packer, Source Control, and CI/CD Pipelines. There's a bit.ly link here at the bottom for anybody that wants to get to this code and the samples. I will have a blog post that has more explanation on this that I will hopefully have up online by the time this airs next week. So you can find that at bit.ly/vmug-automating-templates. With that, let's go ahead and get started. For those of you that didn't hear it the first time, howdy! I'm Joe Hughes. I'm here because I'm a vMug leader, currently based out of Austin, Texas, about to migrate up to Denver, Colorado, and I love to get people engaged in learning. You can find me online on Twitter. I'm at jhughes, since nobody will ever spell that correctly. You can also find me at fullstackgeek.net. Again, we've got that bit.ly link here on the screen, so if anybody needs to take a screenshot of this, I will also drop it in the chat during the session. And with that, let's go ahead and get started. So, for now, let's go ahead and begin with expectations, right? We want to start to understand what it is we're going to get into, especially for vSphere admins, right? So let's level set these expectations, right? This is going to be a quick run through of a sample, right? Basically, we're going to take a look at deploying an Ubuntu template. We're going to take a look at deploying a Windows template, a little bit of wrapper code around that for things like, again, using the StackStorm environment to integrate with some other platforms. We're going to, do things like triggering ServiceNow. We're going to use Packer to actually build our templates. We're going to use Terraform to deploy inside of our environment, do minor testing, and then tear everything back down and basically just stamp this out, right? But again, quick run through on a lot of this. There's a lot of stuff in here. So this is going to be basic concepts, right? Discussing some things from a new perspective, and then hopefully we will understand things a little bit better, right? Is this session going to make anyone an expert? Absolutely not, right? This is going to be explanations, right? It should help you think about things a little bit differently and see some of these basics and some of these components and actions, and it'll hopefully give you another step in your learning journey. So, what are we trying to accomplish here, right? What if we don't do DevOps or CI/CD, right? This is still totally applicable if you're not in a DevOps focused shop, or if you don't have or run CI/CD pipelines currently, right? We're taking something simple and very menial, right? The task of creating our templates, right? To give credit, I mean, I'm sure there's a lot of folks in the audience, a lot of people within the vMug ecosystem that had, perpetually kind of gone back and looked at the blog posts that were put out by Michael White on how to build, say, Windows templates, right? We're taking a lot of that, which was screenshots and things that were in Notepad and text files and a lot of copy and pasting or clicking around inside of the environment, and we're just making it more automated, right? This is for us to have a hands-off approach to deploying templates, where we're able to add in additional scripts and additional configurations, even build these templates out and then hand them over to things like, an Ansible or Chef or Puppet, stuff like that, right? And again, be able to use Terraform to actually spin these things up, run basic tests on them, and then tear them back down. What do we get out of this, right? This is all around, DevOps and the DevOps methodology, right? It's working to create certain specific outcomes, but it's only useful if you want those outcomes, right? Again, we're taking this example to be something very simple, something very menial, right? It's creating templates because it's something everybody knows how to do or can find instructions of how to do it manually. We're just trying to put this into code, right? And if you don't like what this process will bring to you, then don't do it, right? You may not want to do all of the CI/CD. You may not want to deploy things like, Jenkins or StackStorm or stuff like that, right? But you may still get some benefit from understanding the tooling and how these things interact and just how the components work together. Do I need to do this, right? No, you don't. But really think about how you make changes to your environment and how you test those changes to your environment and being able to actually undo these changes within an environment, right? For us and what we're talking about here, right, this is all about the enabling rapid deployment of software, right? And when that software breaks, DevOps is usually meant to equally support, rapid deployment of a replacement version or a rollback to the last known good version. In this instance, what we're doing is we're doing automated testing of, building an actual image, making sure that process completes, handing it over for configuration if necessary, and then saying, okay, all of this completed. We built a valid virtual machine out of this, right? We can go check it into our content library. We can go put it into a repository if we have external repos that are getting replicated around our environments, things like that, right? And just testing to be able to take a lot of these things and just put them together and kind of build out this process. What's the point, right? So even if you're not going to fully automate software and infrastructure deployment pipelines, you should be aware of what the capabilities are when it comes to automating your environments, right? For me, I even go grab the most current version of the Windows ISOs, not every month, but probably every 2 to 3 months, right? Just go get a quarterly image to get what's the latest and greatest build at the time that I need, run a handful of deployments against that to automate injecting the drivers that we need, right? I use paravirtual SCSI adapters. So I inject those VMware drivers inside of there. I go grab the most current version of VMware tools, because that even bit me in the butt when I was doing some tests on some of this because, in the last couple of months, in the last 2 months, I think, there was an expiration on VMware tools and the VMCI driver not installing properly because there was a certificate on that version of the tools that was a public cert that expired, right? Just to give an example of simple things like that, right? It was something that, from one run of my templates builds to the next, something didn't work. And I went to go look in the logs and end up finding out, oh, hey, look, this is even something with VMware tools where it was just out of date. And I needed to go run, a patch version up to like 11.2.6 to be able to get something that actually worked in this pipeline, right? But I didn't have to interact with any of that, right? This thing ran on a schedule. It did all the things that I built into this pipeline to go run for this. And at the end, it either succeeds or it fails. Well, this time it failed. So my interaction, rather than spending multiple hours to go try and run this thing or manually check it, every 20 or 30 minutes to see when it's done and stuff like that, was I got an email that said, oh, hey, there was a problem with your build. Oh, well, that's interesting. Let me go see what this is. And then started digging into it, right? Otherwise, typically what happens is this pipeline runs on its own and it requires no interaction from me, which is the goal, right? That's what we really want to have. That is our plan. Now let's go ahead and jump into the tools. So when we start discussing the tools, we're going to start with StackStorm here. This is a robust open source automation engine, right? Really think of this being, a tool that has multiple components into it, but it's the IT automation version of if this then that, right? It's all easy logic. But it's intended to be event-driven automation. That means we have things like sensors and triggers and actions and rules, right? So we can put all these components together to say, oh, this sensor detected this specific thing, or it triggered an alert or an event for this. So I have an action I want to happen on this, right? Or I want a rule to be in place that says, things shall always be this type of thing. Then we have the ability to put in, workflows, right? Or install packs, right? Packs are going to be these components that other vendors can put into the environment where you can just go say, oh, I want to subscribe to this, right? I want to use ServiceNow. I'm going to go install that pack. You can build your own packs as well, where we define the workflows that we want. We stamp, our name onto them, and these individual actions that we're using, or these subcomponents of the other vendors' packs and their actions, right, can become our own workflow, and we can define it in our pack to make it easy for us to leverage inside of our environment. And lastly, audits, right? The capabilities to go back and look at any automatic or any manual action that was triggered inside of our environments and see what actually happened, right? And have logging for this. Very, very cool capability to have. And again, all this open source, super easy to install. I'm running this inside of Docker in my environment. Quick and easy to get up and running. I want to say the first time I did the deployment of it, it was maybe like 15 minutes to get this thing up and going, and then I was just clicking around like crazy and finding and playing with things inside of the tool. Packer, right? So this is where we're starting to get into, HashiCorp tools, right? This is the first one we're going to take a look at, which it's an open source infrastructure as code tool, but this is all around building of automated machine images, right? We're basically going to define, this is the platform I want it to go to. These are the actions I want it to have for my virtual machine. These are all of the specs that I want to be in the VM, right? All the resources that I've got for it. It's going to be leveraging the HashiCorp configuration language. And basically I have, like an HCL file that defines, one for Ubuntu, one for Windows. I have a set of variables, which are just about the essentially virtual machine itself. And then I have a hidden config file that lives on the server, which says, these are all my essentially like credentials and things like that, right? We'll cover this when we get into the code, but, a handful of files that just define these things that we just tell Packer, hey, go build this. Here's the variable file to use. Here's the build file to use, and go. And it just does everything for us, right? We also have the capability to define multiple platform builds within a configuration, right? In our configs for an Ubuntu box or for a Windows box, we can actually put in that I want a definition of being able to define this to run against the builder for a VMware ISO, or for Hyper-V, or for Vagrant, or KVM, or QEMU, right? Any virtualization platform we want to have these things run on, we can have it defined, that I can do simultaneous builds, right? And deploy to vSphere and to Hyper-V at the same time, or I can deploy to vSphere and I can deploy it to a Vagrant box, or you can even leverage VMware Workstation as opposed to a full vCenter and ESXi environment. And then again, we have these variable files, right? There's the capability of loading in automatically for any that have a specific file extension, or we can have defined variable files that we feed in at runtime. The last thing we're going to get into here is going to be Terraform. Again, another HashiCorp open source infrastructure as code tool. This is all about giving us a consistent CLI workflow, right? Again, using the HashiCorp configuration language, but we're leveraging in this instance declarative config files, right? This is all about desired state configuration, where we define, this is what I want my virtual machine to look like. I want it to be, in this location with this amount of resource for it, right? This is not during our image build. This is during our actual deployment of a VM, right? This is taking the template that we've built in our pipeline and deploying it into our environment, whether this is for our testing in the workflow or to actually go deploy these virtual machines into production, right? We declare what these instances should look like, what these virtual machines should look like. And this config file leverages providers, right? So these providers are existing for resource dependencies. So when we say I need to know things about VMware, right, or I need to know how to work with VMC on AWS, right, things like that. All of those individual providers for different platforms or for different APIs you're going to leverage for all these things within Terraform. Those providers are actually built and maintained now by the vendors themselves, right? So the VMware team actually owns the providers and can update the providers for all the VMware components that we're going to leverage external to what Terraform is, right? So Terraform can version itself and the providers can version themselves. So as there are new capabilities for vSphere or for VMC on AWS, right, those providers can get updated without it taking a full update of Terraform itself to be able to leverage those things, right? So you can manage those dependencies independently, especially if you're using multiples within a Terraform file. And then we have this instance of, or this concept of state files, right? So these are structured configurations where this state says, the last time that we ran a plan of our Terraform and then applied it, we actually ran Terraform apply, it gave us a state file that says, I completed this configuration, I applied this config that you wanted inside of your environment, and here was the end state of it, and it keeps the state file. So the next time we want to go look for this declarative config and see, does my environment still match? When I run a plan or when I run an apply, the first thing it'll do is go validate, does that state still match what it should be? Right. The big point here is you want to be managing these things with Terraform, not outside of Terraform. Otherwise, your state files are no longer going to match what your environment is. This is all about declarative infrastructure and defining and letting these tools manage these things for us, right? So we're managing the code, not poking the VMs themselves to do this sort of stuff. So with this, let's go ahead and switch over and get into the demos and the interfaces. Howdy, y'all. We're here for the demos, and first we're going to start off with taking a look at our repository and just see what it is we're looking at here. So inside of my vmug Packer demo repository, all I've got is essentially a folder for my Packer files and a folder for my Terraform test instance. So within Ubuntu, right, I've got this HCL file, which is actually defining my Packer build, and then I have this auto.pkrvars.hcl file, which is my variables, which will get automatically loaded when we run Packer, along with a folder for setup, which just has additional files and things that we need to actually have within this environment here that are defined in my build. If we jump back up to the root of Packer, we can jump into Windows 2019 and see I've got a similar thing, right? I've got a Packer build file that's defined here, variables getting automatically loaded in, and a handful of different scripts that are here for the Windows environment. And then getting back to the root level, again, within Terraform test, I've just got my main TF file and my vars TF file, which is going to be used within this workflow where Terraform will just deploy our virtual machines to do some testing and then, tear them down once everything looks good. So the next thing we will go ahead and jump into here for starting this off is taking a look at our ServiceNow record, right? So all we're going to do here is just show that we are connected from my internal StackStorm environment to my developer ServiceNow instance. Really all you've got to do for that is just go to developer.servicenow.com, sign up for an instance. And what we're going to do here is just check a look. So see that I have nothing starting with hello for incidents inside of my environment. I'm going to go create a record. The only configuration that I did for this essentially, right, is give it credentials to go log to my ServiceNow instance. And in here, I'm giving it a description. I'm giving it a category, for description of my ticket itself and telling it I'm calling it from StackStorm. And I'm saying I'm injecting this payload into the incident table. So now if I run the same search again from my ServiceNow instance, I should see that I have a new incident that is opened inside of ServiceNow, which is hello from Mountain Regional vMug Virtual UserCon, right? So we have integration with our ServiceNow instance that's working. So we will go ahead and jump into the next step here. Okay, y'all, we are back after a brief delay where I unfortunately had a host that has purple screened on me while I'm in the middle of trying to record this demo. And unfortunately, we are in the middle of packing things up to do a cross-country move, so I'm a little bit short on hardware to be able to try and get things up and running. So unfortunately, what we're going to have to do at this point is basically just take a look at the code, and we're going to dig in a little bit to the workflow for StackStorm itself, and then we will go ahead and do a little bit of a deep dive into the configuration with Packer, so you guys can at least understand the workflow for Packer deployments and take a look at what that was inside of the environment. So here I have a definition for just the actions themselves, right? I'm defining this pack of FSG lab to just be the folder that all this lives under. I've got a single file that's here that's named vmug demo-ubuntu for the action that's going to be run, and this is just defining that there's a workflow file itself, same matching name that's over here that we're looking at. And this just tells us this is the runner type which lives within StackStorm, right? This requesta. If we look at the workflow itself, basically we just have version 1.0. It's a description of a workflow for creating an Ubuntu template via pipeline. And I will go ahead and actually zoom out just a hair to look at this. So we're saying the template name that we're using for this is going to be Ubuntu 18.04 vmug demo. But really the tasks that are running inside of here, right, are creating our ServiceNow incident, which we saw that's at least up and running. We've got that functional where we're giving it a description, we're giving it a category, we're giving a short description and a full description, so these can be different bits of text that you send inside of your environment. We're giving it a caller ID of StackStorm just to know where this incident was coming from. And essentially we have defined, like this action, we have an input, we have the next steps for it, right? So when it succeeds, we publish the incident ID, and the next thing that we do is like do our cleanup of our Git repo, right? So once our ServiceNow incident is created, right, the next steps we're taking a look at here to go in for are, going and cleaning up our Git repository, right? So we've got a target of where this thing is going to go. So we want to clear up what exists here on the host. Then we want to clone our repo coming down from my GitHub box, right? This is just my jhughes vmug packer demo, the destination of where I want to put it on the disk, right? Saying that this is on local host. When it succeeds, the next thing we want to do is create the template, right? So this create template step, right, this task, we'll go run a Packer build, right? We go pull in our original Ubuntu 18.pkr.hcl file, right? This is the defined Packer build that we'll cover in just a minute. And we tell it that the variables that we're going to load, right, these are going to be my, we'll call them secure variables. This is like where I've got my credentials and things. This lives on my StackStorm box rather than within my GitHub repo itself. So everything is local to this box. These files don't get uploaded for these credentials, right? Once this succeeds, the next thing we're doing is provisioning our test stack, which says that we're going to go run a Terraform pipeline, right? I'm going to load in my auto tf-vars file for the variables. The plan lives in this Terraform/tf test directory, as we saw within the GitHub repo itself, right? And then on the back end, where I want to put it is, a different Terraform state file for my Terraform Ubuntu versus my Terraform Windows. Once this finishes, I want to, go ahead and output the info from the test for this once this test stack is done, right? There's another step that I typically have inside of here for Jenkins tests for it, but that gets a little expansive, so I left that out of this demo itself. But typically between the deployment and the provisioning and the destroy of your test stack would be where you would actually do additional testing inside of here. But since we're not getting into the Jenkins and all of the testing itself, right, we're looking at the image build pipeline. I pulled out those steps so we didn't divert into that too much. Then basically we're doing the same thing. We're doing a Terraform deploy. Where we're taking all the environmental details that we have of this to go to destroy the virtual machines that we've spun up for testing, and then we create the CMDB record, right? So what we're doing for that is we're going and creating a record inside of the CMDB for ServiceNow for our new template, right? That we've finished from this environment, right? So we get some of this template data out of this thing that came back from Terraform deploying the environment, right? And we get the details out of that Packer build file. Take all this information and make that part of our CMDB item, right? So we're putting in a template information. We're putting in like what the CPU is, what the memory is, what was the guest operating system on this thing, disk size, right? And then particular object. And then we're closing the incident, right? We're telling ServiceNow, okay, we created this ticket. Everything was fine. We created it properly, so we want to go ahead and close, solved permanently, and that's finishing out our pipeline, right? I won't go into the files for Windows because essentially it's the same exact thing. It's just different names for things rather than Ubuntu. So for that, we'll go ahead and jump over to our Packer builds. Okay, for our quick rundown of what it is we're looking at for the Ubuntu build itself, right? First, we're going to look at our automatic variables that get loaded in here. Basically, all I'm defining here is number of sockets, number of cores, how much RAM is in this thing, what's the type of NIC we're going to put on it, what's the disk controller, disk size for the virtual machine, whether or not it's going to be thin, what's the CD-ROM type we're going to attach to this, and I typically leave in VM video memory, just, if I'm going to RDP to these boxes and things like this, or if it's going to actually have a full GUI environment on top of it rather than just be, just command line interface for it. I like having video memory set for these things. That's just me in preference. OS type, right? This is just going to be defined for the VM itself, so that guest tools know what exactly we're getting into here. And then we're going to use HTTP provisioning to put the pre-seed config file on these boxes. If we jump over and take a look at the actual Packer build itself, right up here at the top, since we're leveraging HCL for this and not the older JSON format for the templates, we have to define all of our credentials, right? So it's just, here's our vCenter configuration and all the bits we're going to put in there. Here's the details we're going to have for our operating system for both the ISO, the family, the version, right? A lot of stuff I've got inside of here. All the details for the VM itself and what's actually coming into it, and then the bits for provisioning, the bits for the build, and then a couple of local variables for, you know, version of date, the scripts folder, and everything that's getting passed to us, right? Now we get down to the real run for all of this, right? So we're saying the source here, the builder that we're leveraging is this vSphere-ISO, and I'm calling this run Ubuntu 18, right? This would be, again, where we could have simultaneous builds and could be doing parallel builds against different environments, or I could be running, you know, an Ubuntu 18 versus an Ubuntu 20, where I'm leveraging different variables, but, you know, can do simultaneous builds for different versions of the OS and things like that, right? We're giving it all the credentials and everything that we need for vCenter, right? Server, username, password, whether or not we're accepting, you know, self-signed SSL certs, data center, cluster, folder, the data store it's going to live on, if we're removing the CD-ROM after the fact, if we're converting it to a template, if everything succeeds, if we're creating a snapshot on this thing, right? Simple basic definitions of all this stuff. For the source of the virtual machine that we're getting into here, right, this source really means the builder that we're going to be running, right? So in this instance, we're running a vSphere ISO builder. We're going to define this run with the title of Ubuntu 18, right? If I wanted to run Ubuntu 18 and Ubuntu 2004 and have all these driven, you know, essentially off the same config files and off the same variables, we could run that, right? As long as we have definitions for any place we want these to differ, we could run, you know, most of this to be the bulk of the same code and 4 or 5 variables that are different, right? But inside of this, we're looking at our vCenter environment up here, right? Our server, the username, password, whether or not we're accepting SSL certs that are self-signed, what's the data center, what's the cluster we're going to put it into, what's the folder we're going to put it into, right? The data store, the CD-ROM, if we're going to convert it to a template after the fact, remove the CD-ROM, yes or no, convert it to a template and creating a snapshot, right? Then I'm defining my guest OS type to get stamped on there just again, so we know what to do for guest interaction on these. What's the virtual machine name itself, right? What notes are we going to stamp out on the VM? For the particular firmware, right? Are we going to run BIOS or UEFI? What are we using for CPUs, for number of cores? Are we going to enable, you know, CPU and memory hot plug? What's the memory we've got inside of here? All the defined variables that we had before, right? The CD-ROM, the disk controller, video memory for it, our disk provisioning for storage, the network adapters, and then we're getting into different things in here, right? ISO paths of what we're going to load for this thing. What's the boot order we're going to use? What's the full boot command, right? This is everything that's going to end up getting passed in for running the CLI installer on Linux, where we have a specific run that we want it to do, right? The floppy bits that are going to get copied over for it are going to be the setup folder, so we have access to these files within the guest OS itself for it to run. And then just SSH, you know, password, username, port, timeout, and then what's the shutdown command. And then the build itself says, go pull from that source of vSphere ISO Ubuntu 18, and within that, right, when we build it, go run the shell provisioner where we give it environment variables, we give it an execute command, we give it, you know, does it expect to disconnect, yes or no, and then what are the actual scripts that are going to be running in this thing, right? The variables themselves that I have defined that live on my StackStorm box that do not get checked into version control are going to be the things of just, you know, right, what's my vCenter server, the username, password, the data center I'm going to use for this, the cluster I'm going to use for it, the folder, right? Some of these things you may want to live in a definition for your virtual machine itself, so they might be in that auto variables file. I typically, you know, play around with these enough. I keep them specific per build and things like that, so I keep them in this file where I'm always kind of thinking about which credentials and which environment I'm putting these things into for, you know, a data center, a cluster, a folder, data store, things like that. So that's just how I have my variable structured. You can do this however you want, right? As long as you have these definitions and you're using them where they're supposed to go, this is meant to be as flexible as you want for it to be, that's specific for your environment, right? And then I'm giving it a username and password. Again, these are going to be used for SSHing into the box to do modifications and tell it to go run specific scripts and things like that. I've defined my build branch as vmug for this demo. ISO file, I'm running, you know, 18.04.5 server for this build. What's the path of where that ISO lives inside of my vCenter environment? And then what is the metadata that I'm stamping out into my logs, into my notes for what this Linux box is, right? For just a quick overview, right? The other things we have inside of here in our setup, it's just a pre-seed config file, right? We're telling it what we want it to do for the install, for the clock setup, for partition management, for passwords, for package selections of what we want to be on this box, right? Stuff you can find anywhere if you go look at a pre-seed config file. Then I'm running a handful of other things, right? I'm running a shell script for doing updates, right? I'm just stopping and disabling things I don't need. I'm running, you know, all my apt updates. Telling it what I want to do for upgrading all installed packages, right? Kernels, kernel headers. setting my stupid little message of the day script, for reminding myself that this is the FSG lab and put the fire out upon exit, to just, stamp some funny stuff into the environment that, makes me smile when I get in. This is our configuration for SSHD, right? So just, doing SSH config on the box itself from the guest side. This is our networking, where we're going and stamping out a net plan for it. In this, it's just me setting up everything properly where I want all these boxes to be DHCP. So after the template is deployed and I go redeploy this for an environment, it's reset back to DHCP, because that's just how I run my lab. Similarly, right, I'm just doing sudoers. I'm adding my Packer user into sudoers. The VMware shell script that's here is just running the install for Open VM tools to make sure that's on the box, and make sure that everything completed properly and that it gets enabled and started at the end. Then I'm running a cleanup, right? Just running a bunch of things to go remove particular packages and stuff that I don't need. This was completely stuff that I found from people that are way more phenomenally smarter than myself at Linux, and basically they said, hey, here's what you should do, for Packer builds. So I copied it, right? It's exactly what we're trying to do here, right? Just, put components together and make things work. And the last thing I'm doing here is minimizing the box, right? Cleaning out some white space, whiting out the swap partitions and things like that, and disabling all of this until reboot so that we get, as clean as possible of a template build to tear things down. So next, I will go ahead and jump over and we'll look at the Windows configuration. Okay, so now that we're here taking a look at our Windows config, similarly, we've got our same automatic variables getting loaded in, right? We're looking at CPU, memory, disk controller, amount of storage we're loading into this, right? Things like this. The OS type that's getting in here. Since this particular build, I did not customize the ISO to flip the bootloader to the EFI version that does not require a prompt. I just give it a boot command of hitting the spacebar, right? Make things simple rather than a bunch of extra work where I ended up figuring out it takes like 35 minutes every time I go download the ISO to, convert everything that I need to, copy it out, get it copied back in, rebuild the image. So it's easier to just run spacebar to, fix things on boot up, right? Just simple things we can do. And then an inline command here for just, getting the event log and clearing it at the end, because again, we're trying to stamp out a template. Similarly, same thing here. I've got, right, it's the variables that we're loading in. These are essentially like all the secrets that are being used. I'm defining a different username and password inside of here, right? Just because this is Windows, I want administrator and VMware 1 bang. It's still using my vmug build branch. In this instance, I'm running a different ISO file for the operating system and for tools to make sure that this thing gets installed. Again, this is even the version 11.2.6, where, from the last time I'd run a build of a template to this time, I'd had problems installing the VMCI driver because the certificate used for signing that had expired in the last couple months, right? So I had to go download a new version of VMware Tools, load it in the box, and run this thing again to get things working, right? But the whole point of all this was, I did all the work one time to build this thing out, and then that's it, right? It's like set and forget. One thing slightly different that we're doing in this Packer build for Windows is we're actually loading in a plugin, right? So we're able to run a Packer init for this and load a plugin that somebody put out on GitHub for being able to interact automatically with Windows updates. Similar to our Ubuntu box, we've got all of our vCenter credentials, the configurations, right? All of our variables up here are just defined for the things that we're going to be running. Similarly, we've got our inline commands and all of these things, the local variables being used for interacting with Packer for this Windows build. Same thing I've got here, right? I'm using vSphere ISO. I'm stamping this one out as a Windows 2019 standard, but essentially the same exact config is what we had for Ubuntu, right? We've got our vCenter credentials and things inside of here. We're defining the virtual machine itself. The only thing that's slightly different here is, right, the path that we're using for the floppy files. In this instance, I'm defining two ISO paths that I want loaded, right? I want my VMware, I want my Windows install for the OS mounted, and I also want my VMware Tools ISO mounted for this thing, right? And then for boot and provisioner here, I'm telling it the boot command is me just hitting the spacebar, right? That was the command that we put in for the variable for it. IP wait timeout, I'm telling it wait 20 minutes to give me a yes or no on did it ever get an IP back as reported by VM Tools. The communicator that I'm using for the build for this is WinRM, so think of this as the SSH for Windows if you don't have much experience with it. The timeout for that I'm giving it is 2 hours, and I'm basically saying, here's the username and password you can use for it, which was my administrator, VMware 1 bang, and I give it a shutdown command of what I want it to be, and the timeout for the shutdown itself to be an hour. If it hasn't shut down at that point, it declares it a fail and basically just tears everything down, right? Similarly here, right, we're running our sources to define that source at build time. We're running a provisioner for PowerShell to just go set my particular power config that I want on this thing, and then I'm running Windows updates, right? So I'm removing anything where the Windows update title is like preview, and then including everything else, and basically saying search for anything where it's not installed and just go automatically do install of Windows updates. Just for the sake of coverage on this, I will quickly go look at the auto unattend XML file for what it is that we're defining here, right? Basically, we're just saying that, again, since I'm running Paravirtual SCSI adapter, right, that comes in with that VM tools ISO file, I'm just giving it the path for this is where you should go look for these drivers as a path that comes in when it hits the WinPE environment. So, right, so before it hits the disk, before it tries to run anything, it knows where to go load that driver and run. I'm running BIOS for this config rather than EFI. I'm telling it, this is the disk layout that I want you to have for the partitions. I'm running Windows Server 2019 standard from the install. I've got my key, I've got my name, I've got my organization, right? Typical stuff that comes in for doing Windows builds, but if you've not done this stuff before, and especially if you've not automated it, you're going to want to find some examples for an auto unattend.xml for different things that you're going to try and do. I tell it at Specialized what I want to do is run a batch script, which I'll cover in a second for just the VM tools install. I'm defining, the administrator, the username and password for it, setting my execution policy for 64 and 32-bit PowerShell before I enable Windows remote management WinRM, right? And then I'm enabling SSH on the box because typically in most of my builds I will also fire off some Ansible configuration on this afterwards, and I'm going to use SSH for that. The Windows VM tools install is a simple, just go run the E drive setup 64/s/v for my, quiet basic. So I actually prompt and I show the UI on this instead of doing it silently, just in case there are problems for this, right? I don't come in and modify this to turn it on or turn it off when I'm troubleshooting. I just leave it on all the time. So if I ever want to, I can just kick off my builds of this, or when I know that the build is happening, I can just go run the command line or the PowerCLI command to go open the VMRC, the VMware remote console, and just watch it, right, and see what happens, right? Sometimes I'll just put this on my second or third screen and just kind of have it there in the background just to see roughly how long does it take for these things to run. For the setup on this, the next thing we're doing is just getting our network connection profile, setting it all to private. I'm doing a quick config on Windows remote management WinRM to just set this thing to allow everything so I can get into the box and I can modify it and do the things that I'm supposed to. Then I can set all the properties for all of the profiles for the Windows firewall to be off, right, and then set the auto logon count to 0, just go reset that, and then I do a quick configuration for the SSHD service on this, and typically at this point this is where I would hand the box off to Ansible, but for now we will go ahead and leave it at this, and we will jump into take a look at what the runtimes actually look like for these boxes. Okay, so even though the test environment is currently down right now, I wanted to at least be able to run, the Packervalidate and the Packer builds, just so you guys could see what actually happens when this gets run. Even if you're running this interactively, right? If you're not running this inside of a CI/CD pipeline, like I said, you may just want to handle your automation of your templates itself. So the first line I have here is this Packervalidate, where I'm feeding it my variables file of this Ubuntu-vars, right? So I manually copied this file into the directory because I normally have it in a different location, and just told it go run, right? And it runs the validation. It comes back clean. It doesn't give me any errors, things like that. So then I run just a Packer build, right? Same exact thing. Tell it what the variables file is. It knows where to find the build definition inside of here, so it just loads it from that directory with just this dot here. Then it kicks off, right? So it's running as we saw in the config file, right? vSphere-iso.ubuntu18, which was our definition. So it starts creating the VM. It adds in all the files that were in our directory, right? Our setup directory to load all those shell scripts and things like that to the VM itself. Copies all that in there and auto generates a floppy image and mounts it to the box. Starts powering it on, and it's waiting 10 seconds just to make sure it boots. Once it's running the boot command in there and running our command line installer for Linux, it waits for an IP. Eventually, when VM tools gets installed after Linux is on the box, it will get the IP address. In my instance, I'm just running everything on DHCP. So then it just waits for it to be accessible for the SSH connection to come up, right? Then it runs, just our update script. So the next thing we'll see that we're doing here, right, is we can see the comments from all of our scripting that's running inside of here, right, that shows up in our command line as we're running this interactively. And we can see exactly what's happening here, right? We can see all the packages that are getting installed in this thing. We'll just scroll down past this. If anybody's run, apt update and apt upgrade, this is what you would expect to see, right? We're just getting this information that's coming back from the guest to run in our command line. So if you're running this interactively, you can just see exactly what's going on in this box at the time. If I'm testing new things, I will typically run this at the same time that I just have my VM remote console up and running to go look at it. And once this is here, right, I'm just setting my configuration. So all these things are set up and installed, right? This is where I hit my message of the day script. This is where I'm running the config files to do my VMware setup, to get VM tools on there, to clean up the box, to minimize it, and do all those things, right? So the last thing that you'll see that it's doing on here is running through this minimize config file. So it's purging lots of things, and it'll go through and it'll wipe the disk and do lots of other stuff for it. At this point, it's removing all of my additional packages that I didn't need in here defined. So let me scroll past this wall of text, and really what I was trying to get all the way down here to show you guys is what it looks like once it's done, right? This entire build itself finished after 24 minutes and 38 seconds. That was a complete install of Linux. That was full patching to get this operating operating system to where I wanted it. It was running a handful of config scripts. It's even doing like wiping on the disk itself, right? Wiping all of this information to clean out the swap space and things like that. And the whole thing was able to be like torn down and finished in 24 minutes. The interaction that I had with it was probably the first 10 seconds where I ran the validate and I ran the builds to get it going. Now, if we jump over and take a look at our Windows 2019 build, right? I did the same thing, right? I'm running a validate. I'm giving it my variables. This one, I'm specifically telling it, right? My variables files that I'm loading are my Windows vars. I'm reloading my variables.auto file to just define it in there, and I'm telling it the build I want it to run is this Windows 2019 PKR HCL file. So it starts running the same thing, right? It creates the VM, it takes all my scripts in the setup directory, clones them into a floppy, mounts it onto the box. It waits for the IP address to be accessible, and then it connects over WinRM to the box. Think of this again as SSH for Windows. Once it's connected, it starts provisioning with PowerShell, right? The first thing that it's doing is just, kicking off a handful of scripts to go through and enable some things, and then it runs Windows updates, right? So we can see here, it just searches for Windows updates, it finds them, it tells me it's installing 8 updates for a total of, basically 16 gigs of stuff that's in here. Sorry, 1.6, 16 gigs. Bad mental math here. And at this point, it just tells me like it's waiting for it to finish, right? It's waiting for all the installers to be in there. It'll do a system shutdown. It'll do pending reboot. It'll come back up. It'll go check for Windows updates again, found another couple of additional updates for another 500 megs, installs, reboots, does all this over and over and over as it needs to. Again, this one took 1 hour and 24 minutes total for it to install Windows, get my configuration on the box, run the updates, verify everything was good, give me it's successful, it stamped out these artifacts for it, and to be done. The interaction from me was running my validate and running my build script, which took me 20 seconds of interaction for it. Okay, and for our final piece here, I just want to show everybody we did actually have these builds that completed, so I get templates that are built out into my Linux folder for any Linux OS. What is the specific, metadata for the OS that I told it of this one, 18.04.5. For Windows, I give it the specific version that it's going to go into, so this is 2019, I'm just put my standard and data center in the same folder. But this is just showing we did have actual VMs that were built. They got converted out into templates when they were done, right? And we had notes that actually got put onto these boxes themselves based on the information that we had here from this. Right, so these builds completed. We do actually have artifacts that are done after the fact, and I hope you guys learned a little bit from this. Thanks. I'll see you guys to close out the slides. Recording again in 3, 2, 1. Thanks, y'all, for coming out. Sorry we had some issues with things inside of the lab environment. Obviously, I was not planning a purple screen while doing the demos. And unfortunately, just with getting ready to do a cross-country move, I'm short on time and additional hardware to be able to try and get this thing up and running. But again, I hope you guys learned a little bit, at least from the concepts of the things that we have inside of here, understand kind of how some of these components work. With any luck, I can put up, again, the full blog post that explains a lot of this stuff and has more of this code. For all the configurations and everything itself, you can find this again at bit.ly/vmug-automating-templates. If you have any questions, again, you can hit me up on Twitter. I'm at jhughes, or you can ping me via email at joe@fullstackgeek.net. My only ask from this, if I did anything wrong or didn't explain it well enough, or if I'm flat out incorrect about any of these things, please reach out and correct me. I would love to make those corrections and make sure I'm not misstating these things. Or I would challenge you to, come out and present at the next VMUG event and do it a little better. So I hope to see you guys presenting soon. Thanks, y'all, for coming out. Have a good one.